Today we are going to discuss about the multi-layer perceptron, in which we have an input layer and the hidden layers followed by an output, and we have multiples of hidden layers. 2 or more hidden layers will be there. So that is the basic difference between a single layer and the multi-layer perceptron, right? Only one hidden layer which is there on a single layer. In a multi-layer perceptron, we have multiples of hidden layers will be there, and this is what specified over here. This is an input of x1, x2, x3 and x4. We have an input of 4 and we have 2 hidden layers followed by an output. This is what the general architecture of a multi-layer perceptron is all about. And here the multi-layer perceptron focus on an feed-forward artificial neural network, as stated with a simple example. We have x1, x2, x3 and x4, which is an input, and we have 2 hidden layers, x5 and x6. Whereas we have this x0 is a BIOS and x1 is your output. Okay, we will be trying to solve this problem using your design thinking framework. Understood here? So this exact problem can be solved by means of a basic input. Here, the input which is given on a multi-layer perceptron is represented on a tabular column. We have all your inputs of x1, x2, x3 and x4, and here weight should be represented, weight of 1 and 5. So these numbers which we have given from x1 to x5, which is a weight of 0.3. Similarly, we need to calculate from the weight w1 to the first hidden layer, and similarly w1 to the next hidden layer, followed by your weights. Okay, weights of w2 and w3, w4 and w5, w6, only 4, and then we have this hidden layers, followed by which theta 5 and theta 6, theta 7, which we call it as a BIOSes. So that value is represented. So generally the first step, as you have stated, this was a general calculation.
So the values in input layers are x1 and x2, x3 and x4 are components. The input thing are 1 and the similar output is 1. And the input for 1 is similar output is 1. And the input for 0 is 1 and input for 1 is output is 1.
So input layers x1, x2, x3 and x4, and what is the input which was given, which is already given. This is an input, and output is without any error. What is our achieved target rate? That is what specified here. So without any error, we need to focus on the target. Target is 1 should be 1. Whatever input we are getting it, same output should be there. Yes or no? So that's why we have given us output as 1101. Got this first step? Yes? Yes. We need to calculate the hidden layers of x5, x6 and x7. Okay, so x7 is BIOS. Whereas the formula for this is I5 is equal to x1 into yw15 plus x2. This was the exact formula. And where whatever input which is given on the table calculated for the I5, and what is I5 value is 0.4. You divide it into 2 columns. Based on this input, you have to fetch it out your theta 5. Theta 5 is equal to 1 plus 1 divided by 1 plus e to the power of minus 1 by 5, which minus 1 by 5 is the value of, what is the value we got it? 0.4. 0.4, which is 1 plus 1 divided by 1 plus e to the power of minus 0.4. You have to make use of your calculator. Calculator, you have a power. Power no. So you can find the calculation of e to the power of minus 0.4 calculation, and that value should be added with plus 1. Okay, and then that value should be divided. Final value is 0.599. Similarly, you need to calculate your x6 and x7. What will be the calculate value of x6? Yes, Vikram. What is the value of x6?
1.2.
1.2. Yes, Charan. Minus 0. So calculate it first. Okay. Your design thinking framework will be discussing right now.
As an empathy of the given problem. So the first point is understand the problem. So we need to clearly define the problem that the MLP to solve, such as image classification or predictive classifiers.
Identify the stakeholders. So recognize the end users and any other stakeholders involved.
The define will be carried out by the Vishalini.
So in define, we can simply say it like clearly articulating the problem, which means we want to define a problem statement, and we need to specify the goals and the objectives of that.
and it also explores hyperparameters, which tells you the criteria for success such as accuracy, prescriptions, and recall, etc.
As the ideate will be explained by the Sunil Sanjay as well as Sanjay Krishna.
Brainstorm with the MLP architecture, we can generate number of ideas to the structure.
Hyperparameters. Discuss about the learning rate size and instruction exploitation.
Out your prototype.
So first in prototype we need to select our framework, ma'am. What kind of framework means like suitable deep learning like that, ma'am. For example like PyTorch like that.
And to build a basic model, we need to create a prototype MLP with minimal complexity to validate the architecture.